Good afternoon, everyone. The people who are curious to know about the black hole, here comes the poster presentation. Black holes are a constant source of fascination to many due to their mysterious nature. The basic definition of a black hole is an object so massive and so dense that nothing, not even light, can escape from its gravitational attraction. It is formed by the death of massive star. In this presentation, you will come to know how the black hole is formed, types of black hole, basic terminology, and great work of scientists. Here comes our first Chandrasekhar limit. It is a maximum mass of a stable white dwarf. If the star's mass is less than the Chandrasekhar limit, it can eventually stop contracting and settle down to a possible final state as a white dwarf with a radius of a few thousand miles and density of hundreds of tons per cubic inch. White dwarf is supported by the exclusion principle repulsion between the electron and its matter. One of the first to be discovered is the star that is orbiting around the Sirius, the brightest star in the night sky. This concept was given by Chandrasekhar, who was awarded Nobel Prize in the field of astronomy. Here we see a formula m limit, which is the Chandrasekhar limit. Now comes the Oppenheimer's work. It explains why the light cannot escape from a black hole. It also tells how the gravitational field at the surface becomes so strong that the light cones are bent inwards so much that the light can no longer escape. Oppenheimer-Volkoff limit. It's basically upper limit for the mass of a neutron star beyond it must collapse to become a black hole or possibly a quark star. It is analog to the Chandrasekhar limit for a white dwarf star. Now we will discuss the basic terminology of a black hole. First comes event horizon. It is a critical boundary beyond which nothing, even light, cannot escape. It is formed by the path in a space-time of the rays light that just fall to get away from a black hole, hovering forever just on the edge. It will be interesting to know if two black holes collide and merge together to form a single black hole. The area of event horizon of the final black hole would be greater than or equal to the sum of the areas of the event horizon of the original black hole, and also the area of event horizon increase whenever the matter fall into a black hole. Now here comes the singularity. According to general relativity, a gravitational singularity exists at the center of a black hole. Singularity is the region where the space-time curvature becomes infinite. The singular region has zero volume and is thought to have an infinite density. Here the curious question lies that what might happen at this singular region? A wormhole, time travel, a portal to another universe. Next is Schwarzschild's radius. The radius at which mass has an escape velocity equal to the speed of light is called Schwarzschild radius. It is a distance from the center of a black hole to the event horizon. It depends upon the black hole mass. Heavier the black hole, more is the Schwarzschild radius. No-hair theorem. It tells about the black hole can only have three fundamental properties: mass, electric charge, and angular momentum. Scientists think the smallest black hole are small as such just an one atom. Now we will discuss the types of black hole. The first type is the stellar and the second type is supermassive. The stellar, it has a mass up to 20 times more than the mass of a sun, whereas supermassive have mass that are more than the 1 million suns together. The example of the stellar black hole is Cygnus X1, whereas supermassive we have in our own Milky Way galaxy, that is Sagittarius A. Now comes the primordial black hole. These black holes have smaller masses that were made by the collapse of irregularities in the early stages of the universe, basically after Big Bang. These are the hypothetical black hole. Formation of a black hole. The star burns energy in the form of nuclear fuel, as we know, and this energy pushes the outward and balances the inward pull of a gravity. And when the stars run out of fuel, it can no longer generate any push against the gravity of its mass, and the gravity forces everything in towards the center of the burned out star, and the core collapses into the black hole. And this is how the black hole is formed. And now here comes the two curious question. How do we know the presence of a black hole if we say not even the light can escape from it? So how do we know? So there are two ways we can detect a black hole. First is gravitational and next question is what would happen if an astronaut fell into a black hole? The answer lies here. The gravity gets weaker the farther you are from the star. So gravitational force on the astronaut's feet would be greater than the force on his head, and this difference in the force would stretch a astronaut like a spaghetti or tear him apart before the star had contracted to a critical radius at which event horizon is. Thank you everyone.